Okay, see Lindelof video. It's expressing radicals in exponential form. So here we have a couple of radicals, and any radical can be rewritten or re-expressed in the form of a rational exponent. So here we go with this. This is actually really simple. I just want to show you this really quickly. So here we have the square root of 2, and I'm sure you already know this, but if you have a square root, it does have an index. It does have a root, and that root is 2. We just don't show the root. It's just assumed. Like if you have a positive 5, you don't have to put a positive sign in front of it. If it's not a negative, you assume it's a positive, so you don't have to write the positive sign. Same thing with a radical. If you have any radical and you can't see the root, you assume that root is 2. And also, another truth, anytime you see a number, for the example 2, if you don't see an exponent attached to that, that exponent would be 1, right? So I'll show you why these two things are important. So I'm going to express this in exponential form. So the base is still 2, so there's the 2. And now we're going to get a fraction here. So here's the solidus of the fraction. This is always true, that the root, the index, goes to the bottom here. So this is called a root. And one way to help you remember this is that if you can remember this is a root, a square root, roots are at the bottom of things, and this root 2 goes down here. So there's a 2. If you don't remember that any number that doesn't show an exponent is raised to the first power, this gets a little bit weird. But we're remembering that. So this one right here goes there, right? So this 2 came from here into the bottom and gave us this. So let's look at this one. It's exactly the same process, right? I have a base of 5, so here's my base of 5. Right? I know I'm going to have a rational exponent, so there's the solidus, or the fraction bar, whatever you want to call it. We remember that this number is called a root, right? That this is the third root. Roots are at the bottom of things, so it goes to the bottom. And this 2 is the exponent. In this case, we can see the exponent clearly, and the exponent is 2. I'm going to do 2 more examples, and the reason I'm going to do them is because they are a little bit different than this and likely to be seen. So let's just push really quickly through this. So sometimes you see it, and you'll see the radical inside of parentheses and the exponent on the outside. It doesn't mean anything. It is exactly the same as writing it this way. Exactly the same, right? So because it's the same, when we rewrite it, we have our base of 2. The root is 4, so 4, and the power is 5, so we get 2 to the 5/4 power. And the last one is a very similar example to the first example we did, but I wanted to go over it one more time just to see it. We are going to look at this, and we're going to keep in mind that this 2 is raised to the first power. Super important, because people screw this up. They don't know like how to make this rational. So making this rational, hopefully you can see the 1/3 right here. So we're going to write in our base. Our base was 2 here and here. This is also called the radicand. Anything inside of a radical is called a radicand, right? We're going to put in our solidus. So here's our solidus, and then we're going to put in the numbers as we see them. This is an index, a third root. Roots are at the bottom of things, so there's the 3. We know that any number that doesn't show an exponent, we assume an exponent of 1, so this one is this one. All right. Hey, I hope this is really helpful. If you haven't already subscribed, please do. And if you have comments, please leave comments. If there's something that you have a question about, or if you have a question about something you would like to see, please let me know. All right. Thanks again.